problem, we're given a quadratic equation to solve, and we are to do it 3 different ways. The first of which, I am allowed to use my graphing calculator, and suppose I was on the home screen, press y equals, and I'm going to type one side of the equation into my y1, that's x squared, and then plus 4x, and then as a second equation, so either press down or enter, and then as a second equation type in the 21. So if you're going to do it this method where you don't subtract the 21 over, you're going to have to change your window so that you can see that high. So for example, y equals 21 is a horizontal line through 21 on the y-axis, and if you press window, in a standard window, the highest that you're allowed to see is y that is as high as 10, and we're graphing 21. So you're going to want to change that y max to at least 21. On some of the other calculators, you're going to want to go a little higher, let's say 25. And the reason you'd want to do that, let me just press graph now, is that the older calculators use this room up here to type things on the calculator. The newer calculators don't do that, but at least my emulator doesn't. But you're going to want to leave a little room up there so that when you hit trace, for example, at least some of the calculators write that text right there over the graph, and we don't want to cover up the intersection points here. So the solutions you can even estimate are about x equals 1, 2, 3. Somewhere around x equals 3, the output of the quadratic is 21, and somewhere around 1, 2, 3, 4, 5, 6, I'd say about -7. Somewhere around x equals -7, you also get an output of 21. So I'm guessing -7 and 3 are my intersections, but that's just a guess. I need to verify using my intersect feature. So I'm going to press second trace to access the calc menu. Option 5 is the intersect feature, so I'm going to press 5. And it asks me, is this one of the curves? Is this the first one I want to consider, the quadratic? And I say yes by pressing enter. Then it says, is y equals 21 the second curve? And I say yes by pressing enter. And the guess, you can just press enter. What it does is, if I was to guess right here, it would find the rightmost intersection because I'm closer to the one on the right than I am to the left. But for example, suppose I wanted the one on the left and I didn't want the one on the right. What you could do is left arrow over, and eventually I'm going to have to do this anyway because I want both solutions, and you put your guess over there. You actually have to press enter a third time for it to actually say the word intersection. So notice to get an output of 21 that my quadratic had to have an input of -7. So x equals -7 is one of the solutions I get via graphing, and the other one would be to repeat the process, pressing second trace, selecting option 5, and pressing enter twice, once to say that's the first curve, a second time to say that that's the second curve, and then this time on the guess make sure that you trace over to the right, and you don't have to be a good guesser as long as you're over there closer to the one on the right. When pressing enter you'll get the one on the right. So x equals 3 is the other answer. So I'm done with the calculator. That's what I got when I used the graphing method. That was step 1, or method 1 if you will. Method 2 on factoring insists that you get a 0 on one of the sides of the equation. So what I'm going to do is subtract 21 on both sides, giving me x squared plus 4x, and because there's no like terms over here, I'm just going to write them all down. And on the right hand side I accomplished my goal. 21 subtract 21 is indeed 0. The next step in factoring is, since this is a trinomial, in fact it's very specific trinomial, has a leading coefficient here of 1. And when your coefficient on the x-squared is a 1, it makes the factoring much simpler. So it's going to factor as two binomials. In fact, you can think of this as the reverse of foiling. You have to fill in the blanks for 4 terms, and whatever those 4 terms come out to be, they have to be such that when someone does the foiling method, meaning take this thing and multiply by that, they would get the first term here of x squared. So what you're going to do here is put x in this blank and that one, and x times x would give me the x squared. And if you know how foiling works, there's a multiplication from this one to that one, and from this one to that one, and that generates the middle term. That's the complicated part about the problem. Whatever you put here as numbers, these two numbers have to multiply to give you -21. So I need two numbers, fill in the blank, that multiply to give negative 21, and it turns out because this leading coefficient is a 1, this problem simplifies down to be such that those same two numbers you pick here that multiply to give you negative 21 have to add up to be the middle coefficient, the number in front of the x, and for my problem that's positive 4. Had it been a negative, you would include the sign on this, but in this case it's positive 4. So now I just start making all combinations I can think of ways to multiply numbers to give me negative 21. Now, to get it to be multiplied together to give me a negative, I have to assign one of these to be a negative. You could have negative 3 times 7, or you could have positive 3 times negative 7. You could have negative 1 times 21, or you could have a positive 1 and a negative 21. All of these pairs multiply to give me negative 21, but there's only one of those four pairs that add up to be 4. So if you took these numbers and added them, the question would be, do they add up to be 4? And the answer in the first case, of course, is no. So if you went down the list, you'd eventually come to this guy and realize that negative 3, 7 actually satisfies both conditions. Negative 3 times 7 is negative 21, and negative 3 plus 7 is 4. So this is the only one of the four pairs there that would add up to be 4. So these are the two numbers that I put in the blanks over here. So I'm going to put a subtract 3 and a positive 7. And if you want, you could FOIL this to make sure that it checks and see that x times x is x squared, x times 7 is 7x, negative 3 times x is negative 3x, and negative 3 times 7 is negative 21. And you combine those middle terms to give a 4x. This just proves that I didn't change the problem, that this trinomial in factored form is equivalent to this. The idea now is that we are now sitting with a structure such that if you were to replace x with a number, what you would have here is, putting a number in for x here, you'd subtract 3, and this would be a single number, I'll put a blank there, and it's being multiplied by another factor, for which if you were to replace x with a number, you would add 7, and it would basically end up being just a second number there. So the structure is we have one number times a second number, and when we multiply those two, you get 0. The only way that this could happen is if one of those numbers was 0. So for example, 2 times 5 is not going to give me 0, right? The only way I can think of two numbers being multiplied to give 0 is if one of them is 0. So this is called the zero product property. It basically says, as long as one of these factors is 0, this will be a true statement. So you end up setting each factor equal to 0. To figure out the x value that makes that factor 0, you would simply add 3 on this one, and negative 3 plus 3 simplify out to give you adding 0, so I won't write that. 0 plus 3 is 3, so that gives me one of my solutions, same as I got by graphing. And on this one, you'd subtract 7 on both sides, and here you'd get x. 7 minus 7 is 0, so I won't write that. And 0 subtract 7 is negative 7, giving me the other solution that we got when we found the answers graphically. So this is just another way of getting an answer, and I'm going to move to the quadratic formula. If you have an equation of the form ax squared plus bx plus c equals 0, notice mine's not set equal to 0, if you can get it in that form, that you can find the solutions by using this formula, the opposite of b plus or minus the square root of b squared minus 4ac, and then all of that gets divided by 2a. So this is just a formula. We don't show in this video where it comes from. It just says it would represent the two solutions to this equation if you put it in that form. You need only identify the a, the b, and the c for your problem and substitute in for those letters there, a, b, and c. So to get this equal to 0, I would have to subtract 21 on both sides. We did this step a few minutes ago when we did the factoring. No like terms to combine on the left, so I'm just writing them all down. On the right hand side, 21 subtract 21 is 0. So now that I did that, if I line up my problem, now that it's equal to 0, with the general equation for the quadratic, you see that my a would be 1, my b would be 4, and my c would be negative 21. All I'm doing now is putting those numbers in for those letters over here. So we have that x is equal to The opposite of b, well, b is positive 4, so the opposite of that would be negative 4. We have an adding case and a subtracting case, which is going to give me my two answers. b is 4, so we're going to have 4 squared, subtract 4 times a, which is 1, times c, which is negative 21. And all of this is being divided by 2 times a, where our a, again, was 1. So simplifying down step by step here, I get that this is equal to negative 4 plus or minus the square root. Now let me look at this radicand for a second here and just look at that, and that's what I'm going to put in here. We have that 4 squared is 16. You can think of this as a negative times a positive times a negative. You'd end up saying that negative times negative gives you a positive, so this ends up being 16 plus. And what you'd get here is 4 times 21 is 84. And then if you were to add those together, you'd see that you get the number 100. So this basically is the number 100. And if you want, if you like terminology, that 100 has a couple different names. In general, whatever is under a radical is called a radicand. But in the specific case that you're using the quadratic formula, this guy here, if you're interested, b squared minus 4ac, is called the discriminant of the quadratic formula. 2 times 1 is 2. I forgot to do that. So now what we have is that the square root of 100 is simply the number 10. This is where I'm going to break the problem down into two pieces. One of the answers would be negative 4 plus, and remember the square root of 100 is 10. And the other case would be if I wrote exactly that down again. So I'm going to write and. The other solution would be negative 4, and it would be the one where you consider this as subtraction. And the square root of 100 is 10. So if you let me simplify down, negative 4 plus 10 is 6. So I get 6 over 2. And I also get that, if you remember right, these are x values. So I get x equals 6 over 2, which of course is 3. And I get negative 4 subtract 10 is negative 14 divided by 2, which is negative 7. And no big surprise, right? We got the numbers negative 7 and 3. 3 different ways now.